Hi everyone, it's Miss Lloyd yet again, coming to you with some trigonometry. We're looking at trigonometric addition formulas. I've been doing this too long. Anyways, so these are the addition identities for sine and cosine. So if we have some angle, so sine of some angle, and it's not an angle that we're used to, so it's not something that we use typically in the unit circle, then we can try to break it up into two angles that we do know in the unit circle that we've used for the hand trick and whatnot that you can find in one of my other videos. And so here are different ways. So if we can split it up with two that add together that we know into something that we don't know, we can split it up this way using sine of the first angle times cosine of the second plus cosine of the first angle times sine of the second, and it continues on. Sometimes addition doesn't work, sometimes we could subtract in order to get this other angle. So sometimes you have to be a little creative. I just like to go through the angles that I do know that are pretty. So this is where our alpha and our beta are our well-known angles. And by well-known angles, so I did say that it's the angles that are in the unit circle that are well-known. So like 0 degrees, 30, 45, etc. So basically, these are the ones that we tend to use more often sometimes, the larger ones are in there, but these tend to be the main angles that we're looking at. So what we're trying to do is split up this unknown degree, this unknown angle, into one of these that we do know very well. So our first example, they want us to find the exact, so this is very important, exact. This means that we're not just plugging it into our calculator and finding some decimal for it. That's not going to pan out here. They want the exact. And since 75 is not one of the angles that is well known to us, we want to try to split it up. So whenever I'm looking at this, the first thing that comes to mind, at least for me, is 30 and 45. So I know if I have 30 degrees and 45 degrees and I add those together, that's what would have gotten me that 75 degrees. So since I'm working with 30 degrees and 45 degrees in the cosine of this, that means I'm using this green formula here, where alpha is my 30 and beta is my 45. So I'm just going to plug these into that formula. So from here, I'm going to replace our cosine of 30 degrees with what I know cosine of 30 degrees is. And so using the trig hand trick, or just if you memorize the unit circle, we know that that's square root 3 over 2. And then that's going to multiply with the cosine of 45 degrees, which is square root 2 over 2. And then this is going to subtract with my sine of 30 degrees, which is 1/2, which is in turn multiplying with my sine of 45 degrees, so square root 2 over 2. So this is where memorizing the unit circle comes in handy. It makes it go a lot faster than if you're trying to just look all this stuff up. So going through, I'm going to multiply my two terms. So I've got square root 6 over 4 minus square root 2 over 4. And combining my terms, because I have the same denominator, like denominators, I can combine these. So I've got square root 6 minus 2, square root 2, sorry. So because these aren't the same radical, I can't combine them. They're just going to hang out next to each other, but this is all going to be over 4. And I can't reduce anything because the 4 is not underneath a radical and the 6 and the 2 are. So this is as far as we can go. This is going to be our exact. So exact doesn't mean it's going to be pretty, it just means that we're not using the decimal form. It's likely when they say exact, it's going to be something gross with a bunch of radicals like this. Next one, we're looking at the sine of 105. Again, 105 is not one of my pretty angles in the unit circle, so I want to split that up. Because the 105, I'm going to try to think of something smaller so I can just use the hand trick very easily. And so I'm going to use 45 and 60 degrees. So adding those two together would have gotten me the 105. Since I'm doing sine of these two angles and they're adding, then I'm going to be using the formula in red. So sine of the first angle, 45, times cosine of the second, which is 60, plus cosine of 45 times sine of 60. So now I can replace all of these things with what I know the nice pretty, well, not necessarily pretty, but the solutions to those are, I know sine of 45 is square root 2 over 2. Cosine of 60 degrees is going to give us 1/2. Cosine of 45 degrees is another square root 2 over 2. And the sine of 60 degrees is going to be square root 3 over 2. Multiplying everything together, we got square root 2 over 4 plus square root 6 over 4. So very similar to the one we just did. So we end up with square root 2 plus square root 6 all over 4. Again, we can't reduce because the 4 is not underneath a radical like the 2 and the 6 are. 2 and 6 are not the same radical, so we cannot combine them. They're not like terms as far as we can go. This next bit, we're looking at sine of 165. Again, it's not one of the pretty things that we're used to, so we're going to try to break it up. You can always pause at any time if you feel like you've gotten the hang of this. Do it out yourself and then check with my solution afterwards. For this, I'm going to use 120 and 45 degrees. There are a few different ways to do this. You don't necessarily have to do it with these numbers if there are some others that pan out, but we should end up with the same answer at the very end. So if you use two different angles for this, go ahead and keep going and your answer should match mine at the end. I'm going to speed through this a little bit though, since we've already done one that is sine of two angles adding together. And so our final answer here ends up being square root of 6 minus square root of 2 all over that 4. And then we're ready for the next. Again, you can pause at any time and figure this stuff out on your own if you feel like you've gotten the hang of it, and then check back with my solutions here at the end. So now I've got 255. So then whenever I break this up, I'm going to break it up into 120 plus 135 degrees, of course. So going through this, I'm going to be using the one in green, like I have before. One thing you do want to be careful about when it comes to these is when you're doing out the sine cosine of these larger angles, you want to make sure you're paying attention to what the signs are going to be in those different quadrants. So one thing that can really trip you up is not paying attention to those negatives and where they should or shouldn't be. So our final answer here is the square root of 2 minus the square root of 6 all over a 4. And then this is going to be our last question. This one is a little bit different. So looking at these, it looks like it's already been split up, but each of the individual numbers or degrees, the angles, I don't actually know what those are in the unit circle. They're not one of the pretty ones that we've been talking about before. But I can notice that if I were to, say, add 160 and 20 together, it would end up giving me 180 degrees. So I can see what I would have done to split up 180 degrees and kind of smush it back to where it would have come to the first place. So here it looks like I have an alternating of sine and cosine. So I know that this has to be one of those sine functions. And because I have this addition sign in the middle, that means it would have been adding the alpha and the beta. So that means that I can squish this together, and I'm technically finding the sine of 180 degrees. Since here my alpha is the 160 and my beta is the 20. Adding those together would give me 180. And so the sine of 180 degrees is one of our pretty ones in the unit circle, and it's going to be 0. And we're done. Ta-da! I hope you guys enjoyed this video. If you are one of my students, please locate your homework in the LMS page. Whether you are my student or not, please like, share, and subscribe, especially the sharing, especially in a time like this. If you think that you know someone who might be helped by this video, please, please, please spread the love.